Thank you for coming along to watch my talk. So it's going to be about packaging. I think at this conference we're going to hear a lot about packaging because it seems to be a buzzword in the industry, another one of the areas that seems destined to boom. We have to be a little bit careful with this, that we don't all rush, like everyone rushing for a door at the same time, that we all bump into each other, because it is becoming already quite crowded. But what we do at Industrial Inkjet and the way that we work means that we do work in a kind of a niche way, and I think there's plenty of market for everyone. So what I'm going to talk through in this talk is how we approach the problems and how we've solved them so far, and a little bit about the future as well. So first of all, I'm going to introduce who we are, because there will be, and there's a lot of faces I recognise in the room, but there will be people who don't know who TheIJC are. A little bit about the opportunity in packaging in particular, what the technical challenges are, how we solve them, and more importantly, what we think might be the future for this market. So TheIJC, or Industrial Inkjet Limited, we have two businesses in one, really. First of all, we are the technical sales and support for Konica Minolta inkjet technologies outside of Asia. So we don't cover the Asian area, that's covered by Konica from Japan. We cover the rest of the world, so a small bit. But importantly, our second part of our business is we are a machine builder and an integrator ourselves, which means that we, first of all, learn a lot more about how to use the print heads, because we really have to do it ourselves, but also we use those skills to move the industry along. We are a 10-year-old company. We'll be 11 years old at the end of this year, so we're quite a young company, and by 53 staff is a very small number compared to many of your companies, but trust me, when you start at a company with just a couple of you, it feels like we're huge now. But that allows us to be very agile as well. We've got an installed base of about 190 lines, so not, we're not Kodak or Osei, we haven't got that level, but we have got a lot of experience in a lot of industries. And the key thing is that we understand the technology and the applications to a deep level to ensure that it works. So, not sure what happens here. I'll just zoom in out. So basically, if you look at what it takes to make an inkjet solution work, I've shown this slide at more conferences than I can remember, and I make no apologies for the fact that many people have seen it before, because it's the cornerstone of what makes it work. So, so you have to find the right print head for the right application. Obviously, it's going to be Konica Minolta for us, because they are the best print heads. That's undisputable. But at the same time, we have to choose the right product from the Konica range for the right application. The ink technology, sorry, something's gone wrong with this slide. Let's put this in the middle. The ink technology has to be right for the application, and it is the key thing to get the right ink for the right application, and we only establish that through a lot of testing, which I'll go through later. The software and electronics to do it, we're doing things a lot faster, a lot more complex. You have to have the versatile system to make it work. Pre-treatment as well, getting the substrate ready for printing is another vital part, especially with single pass printing is a very important part. And the post-treatment, as we just heard from Tanya's talk, there's a lot of new technology in UV curing, but it's not just about UV, there's also, for water-based ink, there's new ways of curing as well, and we're always on the lookout for new ways to do that. And one I've added recently is the verification. As we're entering things, as you're entering markets where the data you're putting onto something is important, that you know it's the right data in the right place, verifying you've printed the right thing becomes as important as a lot of the rest of the system. And this part here, the way that we work is that we are at the cutting edge of most of the applications. So each part of that puzzle has to be an enabling technology, has to enable us to do something that someone else can't. That's how, as a small company, we can break into markets. Oops, sorry. So what's the opportunity we're talking about today? So we're talking about providing high-resolution variable data to short-run packaging materials. Now, a lot of that has happened before with things like thermal printing and CIJ, which I'll go into in a little bit later about why that's different to what we're doing. But to actually get high resolution, in a lot of cases, UV inkjet onto packaging at real production speeds, that's the opportunity, because actually there is a demand for that. So a bit of a noddy slide of what is packaging, but just so that we're clear what we're talking about. So the areas that we're looking at, flexible packaging, I know Sean's mentioned corrugated and flexible as well, but basically we're talking primary packaging here, where you're adding something to it. There is also direct-to-product, caps, closures, that market, which we are also very active in, but in this talk, I'm not going to touch that. We'll leave that for one of the other ESMA conferences, I think. Okay? So it's really these two that we're talking about. So I'm going to talk about inline. So inline versus offline. If you go offline, it means you're taking pre-printed stock. You can put it through a secondary machine to put your variable data or your language information on it. That has additional cost, additional in terms of space and money. It can be, one of the upsides is it's speed independent. If you've got a slower machine, you can add 2, 3, 4 machines. You can actually parallel it up, and you can cope with that. So what a lot of people do with some of the thermal technologies. But it can also still add waste, because you've got to load and unload the machines and all of those things. So it's still quite a wasteful technology. And in some of these markets, the cost of the packaging is under so much pressure that waste is a real concern to them. So if we look at Inline, this is actually one of our systems. This isn't actually on a packaging line, this is on a labeling line. We've actually put it on a flexo press. So it's actually a machine designed to do something else, but we've added inkjet to it, so it's completely in line with the process that they're doing. So actually, that example there is even though it's labeling, is quite similar to what we're talking about packaging. There's a company that used to flexo print labels. They used to roll to sheet, take the sheets over to a line of toner printers. I think they had 6 or 8 toner printers, where they would put these things through sheet by sheet. Very costly for them, very slow. We put an inkjet machine on there printing at 200 meters per minute. They could do all of what they needed in one pass, and that's where we're trying to get to. And it reduces the waste, and it just fits with the process. There is another one, which is end of line, which is your outer case coding. Now, that's a very saturated market. It's been inkjet for years, so we're not discussing that here. It's really the inline, where we're in line with the process as the part is produced, and primarily on primary packaging. So what are the technical challenges? The key one there really is high speed, because we have got people wanting to go 200, 300 meters per minute. I've been in this industry long enough that I remember when you were printing 15 meters per minute, everyone was jumping for joy how super fast it was. Okay? Then it was 25 meters per minute. Then it's 50 becomes the standard. Now, when something's going 50 meters per minute, we think it's just normal, whereas before it would have been a major challenge. The higher speeds, the 100s, 200s, are now becoming the new normal. People want to run at those speeds, and they want to use inkjet at those speeds. The second point is ink choice. I've sort of raised it slightly before, but ink choice is key to any of these to actually get the right ink for the application, and there'll be a bit on why that's a challenge. In a similar vein, there's the substrate interaction with the ink and how that works, the pre-treatment side, because that's very important. And it's actually related to the first point, the UV curing. How do you actually cure the ink at those sort of speeds? So if we go for the high print speed to start with. So this is the Konica Minolta product range diagram, where you see they've increased the frequency of the heads and reduced the drop size, giving you higher resolution as they've gone along. So like everyone in the market, there's this push for high resolution, high speed. This is where everyone's going, and Konica are doing it too. The heads that we choose to use for this kind of application come from the Konica Minolta I-series range. And I'll just spend a moment just describing what that is to you. So I stands for independent channel. So if we look at this here, this is the traditional Xar technology shared wall heads, which Konica used to make, and still do. The problem with these is you have the ABC firing. It reduces the speed you can print at. By going independent, you've got 3 times the speed, but you've got half the nozzles. So what Konica did was they took this and they managed to get 4 rows of nozzles into a very small print head to allow you to get back up to the same resolution we would have done with 2 of the shared wall heads. And the result is this range here. And for this kind of market where we're going high speed, the one we're really interested in is the medium drop. That gives us a smaller drop that we get the high quality, but big enough that the time in flight problems aren't as severe as they would be with a smaller drop. So, sorry, I'll just go back one slide. If you look at the typical print speed there, we're talking 80 meters per minute. That's at 360 by 720 DPI. We're still nowhere near that 200, 300 meters per minute we need. So what do we have to do? Well, we have to make multi-head arrays. So we actually have to split the data we're printing up between heads to enable us to go faster. So here you can see where we've got 2 heads mounted side by side so that we can get that high speed. The good thing about the Konica heads is they're a very small footprint, so we can get everything very tight together. And believe me, when you're printing at those speeds, that's really important, that you don't have a spread of nozzles over a distance. We also have to worry about time in flight errors. There'll be some more information about that in a couple of slides. But basically, everything that you didn't really care about at the slower speeds suddenly becomes vitally important. And one of those is the time in flight, just the time it takes from the ink droplet leaving the nozzle to hitting the substrate can cause problems. We also have to have good software and data control to divide the data up between the correct nozzles at those speeds so we don't get any misprints. So on the small footprint, we take the 2 heads and we assemble them into one module. So because they're so small, we can get that less than an inch we can get from the first nozzle to the last nozzle. We've effectively got an 8-row print head there in a very small space. And we can get 2 times the speed. So it's still printing at the same resolution, but we've got double the speed. This is something new from Konica. Say new, it's something they've decided to release outside of their own products recently. And this is the 1800i product, where they're actually pre-aligning it themselves and selling it as a module. And in this case, they're actually aligning it for a 1200 DPI native resolution. But again, it's quite a small module. And if you come to our booth later, we've got one on the table. And although what I'm going to be talking about here is based on the medium drop head, for primary packaging applications, this sort of high resolution will become key. Okay. So, time in flight. If we look here, I'm having the same problem. If we look here, this is the distance between the head and the substrate. So going from 0.5 millimeter to 1.5 millimeter, and this is the print speed. At 300 meters per minute, at 1.5 millimeters away, you've got something like a 1.3 millimeter delay on the substrate between when you eject the drop and when it hits, which is massive, because in Inkjet, we're always talking about microns. So to get it to work, we really have to be down at this end. And even then, it's quite challenging, because we're only a little bit less than 0.5 millimeter. Also, you've got to look at the tolerance of the drop ejection speeds. So if we've got plus or minus 20%, you've got 350 microns of error dot to dot just because of the time in flight. So we need to be down at this lower end to get there. So the heads we used for this from Konica, we got them down to 10, plus or minus 10%, which got us in this area. But also, because of the way the head is constructed, we've got voltage control of the different rows. So we could also adjust the different rows so that all of those time in flight errors came together. It's very easy to say on one slide, this is a lot of work to get this to work properly. And it was the biggest challenge we had of the whole project that we recently did. So that's just saying where we should be. So now some words on ink choice. So if we're talking about primary packaging, I think Lawrence spoke at length at some of this earlier. There's a lot of regulatory and safety issues we've got to consider. So if it's UV, you've got to be talking low migration at least. And if not, it's got to be water-based, and that has some other issues. If it's not primary packaging, you have got a wider gamut of inks you can choose, and that you can concentrate more on adhesion and wetting and those sort of things. So if we look at UV inks, they have benefits and challenges. Again, Lawrence touched on this earlier, that the benefit of the UV ink, actually, as we see it, is the fact you don't get nozzle clogging. It's slightly against what he said, that we find that things like latency, etc., is much better with a UV ink. You can leave it a lot longer between prints, so we have a lot of benefits. The challenge is actually all in the curing, though. There are inks coming along, hybrid inks that are water-based, that are UV curable. So we are seeing there might be some benefits. I think someone also earlier was talking about the build of the ink. We see that with the hybrid inks. You get a much lower build. But the problem is you have a two-stage curing. So you need an IR, then you need a UV. If you're traveling at 300 meters per minute, the length of the IR table you need to get these inks to work is just not possible in most plants. So whilst they have some benefits, there's a way to go yet on how we can actually cure those inks. And then we go on to aqueous inks. Again, they've got benefits and challenges. The benefit is that you don't have all the problems with curing, but you still have problems with drying, and you have problems in the nozzles. So at Industrial Inkjet, when we look at a project, if an ink isn't standard to our range, we have a 7-stage approach to actually approving that it's good to use in the application. First of all, we have to check that it's compatible with the head, that the head's not going to fall apart when you pour the ink in, which is an obvious one, but it has to be checked. The second one is jetting reliability. You have to know that it jets correctly, again, an obvious one. The third one is less obvious to some people, but something we have to do a lot of. In single pass, latency is very important. This is where a nozzle dries or in some way changes when it's not printed. So if you're printing a barcode and you're printing the same barcode for 20 minutes, then you swap to a different barcode, you want to know that that next nozzle will then just start printing. So it's not just about switching the machine off and going for a cup of tea, it's actually a live problem. And that's where we typically get issues with water-based ink. We also do reliability at high frequency. A lot of the testing, the scoping out, is done at low frequency, but because of all the high-speed stuff we're doing, we have to really do extended jetting at high frequency to know that it's stable, because sometimes the performance is very different. The next stage is the stability of the ink in the printhead. We need to know that we can leave the ink in the printhead and it doesn't destroy it in some way over time or clog or any of that sort of thing. Again, vitally important to the machine being fit for purpose for the market. Because in things like packaging where it's going into production, you want a low maintenance product. You don't want to have to keep changing printheads. Print quality is actually quite low down the list, which is sounds a bit strange, but once we know the ink works, we also need to know it works on the substrate. And it's not just about print quality. In low migration, it's also, we may have to do multiple tests on curing and know that it passes the different legislation needed for different markets. That's something we do a lot of work on. And finally, something called machine test, where we actually build a machine with the ink in and we run it and run it and run it and check that it's reliable. Because once this machine's in production, you can't be going, oh yeah, we should have done that, and fixing it afterwards. That's how Inkjet used to be 10 years ago. That's not acceptable anymore. Okay, so some words on ink and substrate interaction. Again, something we do a lot of work on. For the ink to wet correctly on the substrate, we have to take into account several factors. One is the substrate properties, surface energy, also surface finish. The ink properties, the surface tension of the ink, and how it sits on the surface. the curing as well, curing and cure delay, more importantly, and also if we can use pre-treatments or primers. What we are looking for is the ink to sit like this. For a number of reasons. One, you'll get better adhesion. Two, you'll just use less ink, which is obviously a cost benefit. And secondly, if you're using less ink, you can print faster. So that's where we want to be at that end. So that's a combination of ink choice and surface modification of the media. On cure delay, it's important from when you print the ink to when you cure it that you give it the right time to spread. If it's not, I'm not sure how clear that is on there, but if it's not enough, you get stripes in the print because it just hasn't spread enough. If it's just right, you get the desired result. If you leave it too long, it either spreads into the material or it reticulates. Now, a typical cure delay on a lot of our systems is about half a second to 2.5 seconds. Depends on the ink, depends on the substrate. But at 300 meters per minute, if you're waiting 2.5 seconds, that's 12.5 meters. And I don't think there's any machine where you're going to have 12.5 meters between the print and the cure. Sorry, can you just clear that? Okay. So what we need to do is get the surface prepared so that the ink spread is correct, so that we can get down to the 0.5 to 1 second. Sorry, small technical. Okay, thank you. Cheers. So, yeah, where we need to be is down there, just for physical size of the machine. Right, so let's talk about UV curing. So to get the UV ink cured, we need to get enough dose, but we also need to manage the surface temperature, because if we just bombard it with energy, we're going to end up overcooking the substrate. And especially if you start talking about thin film technologies, it's a disaster. You also want to monitor the UV output, because if it's a low migration application, you need to know you're getting the right dose out of your UV system. So non-low migration inks require, say, there's lots of figures, people quote different figures with different reasons, about 300 millijoules per centimetre squared. LM inks often require higher dose, so you need to get even more energy in there. One of the ways that we've done this on some applications is actually, and this is a common practice, this is not revolutionary, but actually turning the UV lamp around 90 degrees, so you're actually getting the dose by getting along the lamp. This is something we have done on the packaging projects, and it's important to get enough dose to the ink. So there's a statement there that current LED technologies are not quite there on output. I'll probably have a big argument with the Phosian and ITL people and et cetera after this, but the reality is they're not. We've tried it, we've really tried, and they're getting there, but they're not there. I mean, some of the things that Tanya was talking about the low wavelength, that's what's going to get us there, because it is surface cure that's the killer. Then talking about substrate temperature, chilled rollers, heat sinks, all of that stuff can be added. But one thing you've got to be careful about is full cure, because you can actually prevent surface, where at the interaction of the surface and the ink, you can get a chilling effect that can actually stop some of the curing. So again, you have to check exactly what your system's doing. And also monitor, you need to be monitoring the UV output. We've done some systems with GW recently where they've got onboard monitoring and we know how much UV is coming out of the lamps. That sort of level of monitoring is needed for low migration applications. And another point is, because we're going faster, we're putting thinner coatings down. I showed a slide earlier where I showed we needed to get a really thin layer of ink. That's great. The trouble is, if it's a really thin layer of ink, you've got more oxygen exposure to the volume of ink you've got, and you do sometimes run into problems with curing for that reason. So because of surface cure problems, you may be looking at nitrogen inhibition. But again, a nitrogen inhibition system that works at those speeds on these systems, well, we haven't found one yet, but we're still looking. So Next one is predicting the future. So I often say if I could predict the next big inkjet market, I wouldn't actually be an inkjet. I'd be down the bookmakers, putting my money on the Grand National, because it's a betting competition. Yes, you can get indicators. I'm sure Sean's got some great ideas on exactly where we're going, as he's presented earlier. But they are only predictions. And there was a time when no one predicted that ceramics market would go anywhere, and that clearly was untrue. So it is dangerous territory. But some things I can predict that will be required to get to the new markets, though. Tighter tolerances on the actual print heads, the actual nozzle-to-nozzle variation. That's coming with MEMS technologies. Conoco are working on it. Many other companies are as well. That will only help these kind of applications, and it is coming. Higher jet speeds, so actually the physical speed of the ink leaving the nozzle, that also has to come to get to these high-speed applications. Also higher resolution, that's already happening. But if we're going into primary packaging, that quality that we need, in the in-shop sort of, you've got to look at the quality and it's going to look right, that's got to be there. There'll also be new ink developments. So faster curing UV is something already been working on, we're already looking at, and it's being worked on by some of the ink companies, so that we can just reduce the amount of UV we have to hit the inks with. Also, the hybrid water-based UV. I'm still quite a big believer that these will be important moving forward. There's a lot of doubters in the industry, but I think they will. I think they do add a lot to the market. Also, new curing. So LED will get there. LED will be improved to the level where we can hit these speeds. I'm sure of it. And like Tanya was talking about with other wavelengths, etc., I think we'll get there. E-beam as well. Lawrence mentioned it earlier. It is an important technology. At the moment, though, it's just too damn expensive for most people. But that will come down. Things like this always do. It will come down and it will become more mainstream, in my view. And there will be other hybrid ways to cure ink. I know of someone working on, I know some other people are working on things. There's lots of technical work in the background, just finding other ways to make this happen. And there will be more in the future. Oh yeah, sorry. Just one note. If we don't get to this point, we won't get true full colour printing at speed. We'll be limited to single colour, just because you cannot get that registration you need at the 300 meters per minute without better heads. So, in summary, for inline packaging, it needs high speed. High speed requires a level of precision that we haven't seen before in inkjet, really, that we haven't needed before in inkjet. And we are making it work with a combination of the Konica heads and getting the design right. It's not easy, but it is possible. So, thank you for your attention.